Hi everybody, today we are going to be looking at gases. When we talk about gases, we are not only referring to the gases at the filling station. No, even the air that is blowing around us is a form of gas, and that's why we say the atmosphere is made of different kinds of gases. So today we're going to be looking at gases. Under gases, there are units that we use. There are units for gas pressure, and some of the units include millimeter mercury, atmosphere, toricida, Pascal, kilopascal, and etc. These units can be used for gas pressure. Today, we are going to be looking at specifically one of the laws of gas. There are different kinds of laws, all right? We got a Boyles law, we got a Charles law, we got a combined gas law, we got the Graham's law, we got the ideal gas law, all right? And today we are going to start with the Boyles law. Boyles law. Under Boyles law, there are two things that will take into consideration: the pressure and the volume of a gas. Holding temperature constant, that is under a constant temperature, that is when the temperature is okay, it's constant. We look at the pressure and look at the volume of that gas. Alright, so let's just imagine if we have a container. Alright, let's say we have a container here. Let's imagine this is a container. This container contains gases here. And we'll have another stuff here that is suppressing this gases. So I mean, this thing is this particular thing is suppressing the gases here. All right. So in the first case, the second case could be let's look at another container of the same size. Okay, so what happened? The gases here are they take up more space than the gases in the second case, because the pressure being existed by this thing is low, so the volume will be high. Here, the volume here, the gases here, the volume the gases occupy is low because the pressure being existed by this thing here is high. So in the first case, we say the pressure is low, so volume will be high. In the second case, the pressure is high and the volume is low. So that's what we said under Boyles law: when the pressure is low, the volume is high. When the pressure is high, the volume is low. When the pressure go up, volume comes down. When the volume go up, pressure comes down. Just get that idea like that. So we have P1 V1, P2 V2. So P1 V1 is the pressure and volume before the change, and P2 V2 is the pressure and volume after the change. Don't forget, temperature is being held constant. By equation, we say P1 V1 is equal to P2 V2. So let's look at the first example. All right. We got a sample problem here. We say at 1.70 atm, a sample of gas takes up 4.25 liter. If the pressure on the gas is increased to 2.40 atm, what will the new volume be? So they give us the first pressure and the second pressure. They give us the first volume, but the second volume is lacking, so we are asked to find the second volume. So we collect data. In scientific work, you always collect data, which is your information. So we say at 1.70 atm, which is the pressure, 1.70 atm, a sample gas take up, which is the volume V1 is equal to 4.25 liter. The pressure on the gas is increased to P2. The second pressure is 2.40 atm. What will the new volume be? V2 is unknown, so we'll represent it by a question mark. Our data is well set. Now, here there is no conversion that is needed because our units are okay. If for any reason we're going to have maybe centimeter or millimeter here, we're going to convert from millimeter or that centimeter to liter. But since we have liter, it's okay. There is nothing wrong with that. If we're going to have one of these pressure going to be in millimeter mercury, or for example, we say torr or Pascal, and the other one is in millimeter mercury, or let's say it's in atm, we're going to do one conversion so that this unit can be able to cancel at the end of the problem. But since they are all matched, it's okay. There is no conversion that is needed, so it's a solution. All right. The formula says, or the equation for Boyles law says, P1 V1 is equal to P2 V2. But V2, but we want to make V2 the subject because it's unknown. So we want to make it the subject. So we divide P2 on both sides. P2 here. P2 and P2 go. We level at V2. So V2 is equal to P1 V1 or P2. Okay. So now V2 is standing alone. So we substitute. P1 is 1.70 atm times V1 is 4.25 liter divided by P2, which is 2.40 atm. So remember, we have atm, we have atm. So what happened? They go away. So atm cancel atm, we left with liter. So V2, if we multiply 1.70 by 4.25, we got that would be 7.225 divided by 2.40 liter. So V2, if we divide 7.225 by 2.40, we got 3.01 liter. And this is our correct answer. That's how we go about solving this problem. Hope this sample will be a great help to your studies as you stay home on the COVID-19 pandemic. Stay home and make sure you turn on your internet for a fresh video every morning.